Hello everyone, and welcome back to CodeByTushu, and happy Wednesday everyone, guys. I hope you are having an amazing week and making consistent progress in your coding journey. As always, we are back with another LeetCode daily challenges. So where we don't just a problem just to solve the problem. We understand the analyzation, the observation, and every single line of the code in the details. So problem today's LeetCode 3691 maximum total sub-array value second. So this problem looks exactly difficult because it's ask us to choose exactly is distinct subquery while maximum the total value, and many people immediately think about brute force, but with the given conditions that approach will never pass. So today's we will learn a much more optimization solution using so without wasting any more time, let's start. So first of all, problem understanding. We are given an array as an integer array nums and integer k. We must choose exactly k distance non-empty subarray, and for choose subarray its value is maximum element and minimum element. Finally, we have to maximum the low total sum of the value. Remember, subarray may overlap, but the exact same subarray cannot be selected twice. Important observation. Suppose we fix the left boundary, then there are many possible right boundaries. Instead of reachabilities maximum the minimum every single times, we progress them using a sparse table. This allows us to answer like maximum in omega 1 and minimum in omega 1. So then we always keeping the currently because subarray inside a property query. So whenever we use the subarray, we think it's right boundaries and push the next candidate back. So this greedy process that we always exact the largest remaining contribution. So approach is solution work in 4 major steps. Like step 1, build sparse table and for range maximum range and minimum range queries. Step 2, for every starting index, consider the largest possible ending index and compute its value and push it into a max heap. Step 3, always pop the maximum value from the heap, add into the answer. Step 4, shrink the subarray by 1 position from the right. If it still valid, compute its new value and puts it back, and repeat the process exactly k time. So guys, let's start Java code and line by line. So first of all, as a given the class declaration and public declaration, but first line is we create a sparse class responsible for answering range maximum and minimum query efficient. So first line is then is store the size of the original array, and next is store the maximum power of to need sparse table, and next is sparse table USD, then store algorithm value of omega 1. So next is calculate the maximum number, then allocate memory for maximum queries. So guys, and next is allocate memory for algorithm value. So Next is efficiently compute floor log to I, and next is use the for loop. Again, so use the for loop, guys. I think now use the for loop. Initialization the first value of the sparse table. Then next is fixed value and max value, and min value as a lengthwise. So nested loop. Again, build the largest intervals using previously compute smaller intervals as a inner loop. Traverse every possible interval of this size. So guys, and store the maximum value and store the min value of the current interval. So next is inner loop and nested loop, then inner loop. Use the in this line condition with condition. So guys, and next is next next line is query max. So query max as a public query max, like return the maximum element inside range, the find the largest power of to these, it's inside the interval. And next is combine two overlapping interval to answer in omega 1 as a return value. Next is query main, expect its return the minimum element instant, and then class solution and public solution. So given that, like class solution and function return the max value total, then next is store array size, and storage size. Then build the sparse table once, and next line is create a max heap that always keeps the highest valued subarray on the top. Then next is for loop, use the and thread every position as a starting index, and compute the value of the subarray. Then insert the condition into the heap loop and storage the final answer, like, and loop again use we repeat exactly case section, and next exact the current base subarray, not subquery. So next is add its contribution into the final answer, and if shrinking is still possible, guys, condition use these. Next, as a compute the value of after reducing the right boundaries. So push the smaller condition back into the heap, then return the final maximum total value, guys. So this. Use the if condition like r greater than 1, then long next variable, so pop offer the new long, and next is return answer value. So guys, code is complete. So guys, code is complete, and first of all save the code and submit the code, or we will wait, guys. And code is right and complete strict. So guys, case 1 and case 2. So case 1 and case 2, and time complexity omega 1 and space complexity omega n log n, because properties query omega n and sparse table n log n. So, and that's if for today's problem. This was differently a much more advanced question compared to the previous daily challenge, but I hope step-by-step explanation made it easier to understand. If you enjoyed this video and learned something new, don't forget to like this video, comment your approach, and subscribe to CodeByTushu channel, and share these videos and your friends preparing for coding interviews. Thank you so much, guys, and for watching.